You've seen weird, wonderful worlds in science fiction. We don't yet know what sorts of life might exist out there, but some of the planets, not unlike the ones in your favorite stories, are real. At NASA, we're studying them. They're called exoplanets. The term exoplanet means a planet outside our solar system, a planet that doesn't orbit our sun. Most orbit other stars, but some are just sunless wanderers out in the space between the stars. Now, just the fact that they orbit other stars means exoplanets are extremely far away. Most are too far to even dream of sending space probes to explore them. So we study them in other ways, like with telescopes on the ground and in space that can observe these far-off planets from right here in our solar system. Here's the thing about exoplanets. They are everywhere. In fact, from our observations so far, we know there are more planets than stars. So, there's our solar system, then there are all the billions of planetary systems in our galaxy, the Milky Way. Then there are all the billions of other galaxies. Basically, there are a lot of exoplanets out there. Each of the stars you see in the night sky is the sun for any planets that orbit around it. But not all stars are created equal. Bigger stars burn way brighter and hotter and don't last as long. Smaller, fainter stars like our sun and red dwarf stars last much longer. But even nice, cool red dwarf stars can have powerful flares that blast their planets with radiation. We're still trying to understand which kinds of stars provide long-lasting, stable conditions that could allow life a chance to take hold and evolve like it did here on Earth. Exoplanets are super hard to see, both because they're so far away and because they're so much fainter than their stars. But we've worked out some clever methods to detect them and even take pictures of some. So what can we observe? Well, for many we can determine their size, their mass, how much they weigh, and how far away from their stars they orbit. From these and a few other clues, we can infer a bunch of other qualities, like how hot or cold it might be on their surfaces, or if they even have surfaces. We can tell that some are gas giants like Jupiter, while others are like bigger, bulkier versions of Earth. For some, we can determine they have atmospheres and even some of the gases in those atmospheres. Most exoplanets are very different from our planet. They have a lot of weird, wild variety, with gas giants much bigger than our own Jupiter, and other planets with oceans of lava or rainy glass, or even gemstones. Funny thing is, looking at how they're arranged as families of planets, we don't see a lot of exoplanet systems that look like ours so far. Many are arranged quite differently, so we might actually be the weird ones. Some planets are closer to their stars, some are super far. Some even orbit multiple stars. Imagine having 2 or 3 suns in the sky. So why do we study exoplanets? Well, our interest in finding worlds with life on them is a big factor. We want to know more about what makes a planet a place with all the right ingredients and conditions for life, what scientists refer to as habitability. How does it happen? How common is it? We think the most life-ready planets are the ones most similar to Earth, with a range of qualities that include similar size and composition to our planet, and being at the right distance from their stars to have liquid water on the surface. These qualities are really challenging to observe from so far away, but we're working on it. Exoplanets teach us a bunch of other things too. Studying other planetary systems helps us better understand the story of our own planet family, including Earth. Scientists detected the first exoplanets in the 1990s, but now we're finding tons more, thousands so far. We're studying their atmospheres and even making weather maps for some. We're surveying exoplanets to understand all their variety. And the more we learn, the more it powers our curiosity, the more we want to explore exoplanets, planets outside our solar system.